in the last lecture how cloud computing is able to um, help us in capacity planning, cost reduction, and organizational agility. So that could be prime reason why some business house will opt for going for cloud computing, right? Um, Basic concepts and terminologies, we will start from there now. Cloud and internet, right? So is it cloud, is it same as internet or is it different as internet? Can somebody share his or her thoughts on this? What is the difference between cloud and internet, if there is any difference? Anyone? Come on, folks. We need to be interactive here. It's a simple question. Just let me know what you think. Cloud and internet are the same?
Sir, I believe that cloud contains resources and internet contains networks on internet is a like many networks.
Very good. Yes. So very important point. I agree. Cloud contains resources, and internet is basically a network. Anybody else? Differences or your views on cloud and versus internet? No one?
So I don't know if it is correct, but can we say that cloud is a part of internet?
Good idea. Yes. You see, I think what we can say is cloud is built over internet, right? So internet is the foundation, and cloud is using internet to provide additional services.
Okay.
Anybody, but you're right. It's part of internet, though part in the sense that it is built over internet. So anybody else? Cloud versus internet, basic idea.
So we need to put that resource to the end users somehow. So internet is a medium with which we can give that service or that resource. So we can enable people to use that resource.
I'm not sure if I have you. Yeah, your voice is not clear, but I guess you are talking about provisioning resources on cloud.
Yes, sir. So in a way, we already have resources on cloud, but there needs to be some medium in between which we can let users get resources. So internet comes to skill. So with the help of internet, users can connect to the cloud technology and the resources that it provides.
Excellent. Yes. So that is a good point, because once we can provision, various resources in our data center. Okay. Let's say we can have a lot of servers and we run Hyper-Vs and stuff. To say that we are ready, people can create virtual machines using my data center. But we would need network and internet to be able to let the people do that. So therefore, internet is a enabling technology for cloud to work effectively. Otherwise, people will have to go physically there at the data center to create virtual machines, which obviously is not going to be very useful. Okay, great. Good points all. I think you are all aware of it. But the main thing is, in cloud, we have resources controlled by the cloud provider. That is, control is one thing. Internet basically is not controlled as such by a single entity, but cloud service provider owns its resources, and the cloud service provider decides which services or which infrastructure or which users will get access to the services, right? And obviously, without internet, cloud is not possible. So cloud is basically a set of services or resources controlled by internet, the cloud service provider for the access and usage. What is an IT resource? What is an IT resource? So IT basically information technology, but it's more to do with anything that we as people or business or anybody who wants to use a resource is trying to access that resource. So any entity which is usable by people for their work, for their any scenario where some resource, some capability is required, for example, computing capability, some storage capability is required, for example, Amazon E3, S3 buckets, right? So any resource that can be used by for such things by people over the internet, which is like the resources in the cloud, we can call it IT resource. But more important also is this thing that this IT resource is it has to be a measurable entity. That is one important thing because, like we discussed in previous lecture, and I also emphasized, it is all about cost in cloud and cost management and return on investment. So everything ends up at the point where you will have to factor in the cost. Here also, you cannot just simply provide a virtual machine. You will have to and call it an IT resource in the cloud. It has to be associated with some costing factor, with some ID, so that its usage can be measured. Okay, so that is an important thing which may skip our minds, that an IT resource is any tangible entity which we can use, virtual or non-virtual, but in cloud computing scenario, it must be associated with some ID. Its usage should be measurable. Okay. On-premise, there is a lot of talk about on-premises and online, right? So on-premises means the infrastructure or the IT resources that are lying on the house, or the office or the physical building owned by not a cloud service provider but by the business house itself. Okay, for example, our DICT server room is an example of on-premises data center. Okay. Similarly, many banks, many business houses still own their infrastructure. They still use their own servers lying in their server rooms in their buildings rather than cloud. So all those things are called on-premises infrastructure. Okay. Here I would also, discuss a little bit about why we need to be aware of on-premises infrastructure. The reason is that cloud technology is new, and there are many companies who are cloud native, start their business starting from ground zero on cloud. But at the same time, there are so many companies which were there already before the cloud revolution came. So not everyone has moved to the cloud yet. Okay, many more years down the line, still people will be moving to cloud. Businesses will be moving to cloud. So it's a real business scenario that how to move to cloud. How as a service provider, if I am a Microsoft Azure, it is a real business scenario for me, a business use case for me, that how can I help a company who already has its servers and everything on premises? How can I help that company to move to cloud? So one option is one option obviously is that I move everything to cloud, but that is very, very rare or unrealistic option, right? It is going to be always step-by-step approach. So there will be many times this situation where I would like some servers, some functionality as a business house to move to cloud, and some continues to remain on premises, because I don't want to disrupt my business, right? I want it to be continuous, and the users of my business should not get impacted. They should not know what is happening behind the scenes. So Microsoft Azure or AWS should help me with that kind of scenario. So for these cloud service providers, it becomes an important scenario where some of the infrastructure of a business house is on the cloud and some is in their or on premises of their business house. So that is called hybrid scenario or hybrid deployment. Okay. So hybrid deployment or hybrid environment is one of the very important scenarios. Hybrid deployment. So in hybrid deployment, some portion of the company's infrastructure is on the cloud and some is on the premises. On premises. This complete thing is the IT or IT infra of a company. Not Azure, not AWS, the business house. Okay, so this is a hybrid scenario, and this is important. This is very important business scenario for cloud service providers, that how they can enable this hybrid scenario for companies to deploy to cloud or move to cloud in steps. It's also not only about moving to cloud. It might be a policy, let's say for some business house, for some bank or some other such entity, where they don't want, by policy they want the critical data, okay, to remain inside the physical boundaries of their server room. It could be a policy, right? Because nothing is more secure than being physically contained. Your computer where you are keeping your data is physically secure, right? Nothing is more secure than that. So it might be a policy. So hybrid scenario need not to be only during the time when the company is moving from on premises to cloud, but it could be a permanent scenario as well. So the on cloud, on premises, okay, and hybrid. These scenarios are very important for service providers. They will provide every possible way to help the customers, because moving the customer to on cloud is what their business is basically. So you should be well aware of this, and a hybrid is not an unimportant or side scenario. It is one of the prime scenarios that they provide services for and provide the paths how a business house can move their scenario, their infrastructure from on premises to the cloud. Okay, then we have cloud consumers and cloud providers. Okay, important difference: cloud providers are like the service providers like Azure and AWS. Cloud consumers are any user. So cloud providers, they are basically cloud service providers like Azure, right? AWS, Google Cloud, IBM, and DigitalOcean, any such cloud service provider. Cloud consumers, importantly, can be individual users, right? You are logging onto your Google Drive, it's a cloud scenario, or they could be business houses, okay? They could be NGOs, they could be government entities. All these guys who are using the services of cloud providers are basically cloud consumers. Yeah. Then let me move this. So then we have got this scaling. Scaling is also important, and I think there should be some diagram in these slides. So we have got scaling as an important aspect of cloud computing. One of the primary reasons, like I illustrated yesterday in my lecture, is the scaling part, right? One of the primary reasons or primary capabilities that cloud provides us is scaling, and it could be both up, scaling like further or scaling down, both, right? Like we discussed. There are two kinds of scaling. One is scale up or vertical scaling, and second is called horizontal scaling or scaling out. So if I have a laptop, okay, and it has got, let's say, 8 GB of RAM, and I am feeling that it is slow, I go to market, I get from 8 GB of RAM, I upgrade it to 16 GB of RAM. That is an example of scaling up, vertical scaling. Okay, an existing resource, I am increasing the capability of that resource. I am increasing its disk, I am increasing its memory, I am increasing, maybe adding more CPUs to it or cores, better CPU to it, but the physical entity of that ID resource remains same, unique, same thing. The ID of that ID resource will be same. Its capability increases. That's vertical scaling. Okay. So, but horizontal scaling is you are adding additional computer in parallel to your existing computer, or additional resource in parallel to your existing resource. So this example, that is called horizontal scaling. Like database we have, right? We have database partitions. If we increase on the right side, if we increase the size of the partition, a particular partition, and user opts that originally, when I started using SQL Server or SQL Service from Azure, let's say, I was in standard tier. Okay, I move because of capabilities that premium tier provides me, more speed, more space, okay, and some other capabilities. I decide that I will upgrade from standard tier to premium tier. That is a vertical scaling because my database service remains same, or database entity remains same. SQL Server on which this data is housed remains same, just that its capability increases. Its input output operations capability, the number of operations IO it can do is more, the size of databases can be more, things like that. Okay. But if I come to the left side, if I add additional servers which manage my same database, okay, then it is horizontal scaling. Okay, I am adding additional partitions to my database. That is horizontal scaling. So it is important to know that both scalings could be useful. Okay, but many times, or obviously, vertical scaling will have its limitations. You can go only up to so much, right? But horizontal scaling could be virtually unlimited internet, cloud computing, all these things are possible because of the distributed connected system. That is kind of horizontal scaling, right? So horizontal scaling is always desired, but in many scenarios, you will have option of vertical scaling as well. Okay. So anybody has any doubt on difference between horizontal and vertical scaling? So so the vertical scaling is called scale up, and horizontal scaling is also called scale out. Scaling out, meaning bringing in more partition. Scale up means existing resource capability is increased. Okay, cloud service, any service or any way to use IT resource is wrapped in a cloud service. So, for example, if I want to use a virtual machine is an IT resource. The interface or the steps that Azure or AWS asks me to go through, like providing the name of the virtual machines, its operating system, and all, that is the cloud service corresponding to be able to create a virtual machine for the user. So any uh, governance of using an IT resource is going to be through a cloud service. Cloud service consumer, again, anybody who is cloud consumer will have to, if they are using some IT resource, will have to use a cloud service, and there will be cloud service consumers. Okay. Now we move to discussion on cloud delivery models. Okay, and there are three delivery models: infrastructure as a service, platform as a service, and software as a service. So, what is the difference, and what are these IaaS, PaaS, and SaaS delivery models? So, why they are called cloud delivery models? Because, just a second, delivery models, because the way the consumer or the cloud consumer uses the IT resource, based on that, it will be categorized into infrastructure as a service, platform as a service, or software as a service. Okay, we can discuss using this example. So we have got this, from this left side to right side, increasing or shift of the responsibility, responsibility of what? Of IT resource management. Okay, IT resource or infra management. So let's come to the on-premises first. What happens in on-premises? We start with the basic thing. We want to ultimately, I want to run some application on my data center, right? So that other people can use. For example, DA students need to log in and register their courses and all. So that is my ultimate goal. But for on-premises, I'll have to start from the bottom. I'll want to make sure that I have networking in place. Then I have a machine which has got this storage space, right? And then on top of it, I will install some servers. Maybe if I want multiple servers for multiple machines on the same server, I will use virtualization and operating systems, right? And then on that operating system, there might be some middleware. If my application is a web service, right? So I will have to devise or add some web server on here, right? Runtime could be like .NET or Java runtimes, right? And then data, meaning the application will have to use the data, so I will might install some SQL or database on that, and ultimately the application is running when deployment happens, when I deploy the application. So as you can see, as a provider of this application, I am a DISCT administrator. I am providing this application for my students and faculty and other staff to use, right? So me as a administrator or the service, I am providing this application as, let's say, DICT service provider. So I am a DICT service provider for my users, which are faculty and students and other staffs from DICT. I am responsible for this whole stack from here to here, right? So, meaning if something goes wrong, all the way from some SQL needs an upgrade, or IaaS came down, or operating system needs an update, or some networking cable broke down, or storage failed, for all these things, I am responsible. Okay. Now let's say we move to the second part here. Infrastructure as a service, IaaS as a service. So what happens in IaaS? Now, what I do is, again, my goal is as a DICT service provider is to provide the same application, which I was doing in the on-premises scenario. Same user base, everything from user side is same. They don't have any clue what is the difference between these two deployments. But instead of me buying the servers and storage and provisioning all that, I create one or more virtual machines. Okay? Or compute instances, to be more generic. Virtual machine is more Azure terminology, which is quite general anyways, but technically Azure compute instances are called virtual machines. AWS instances are called EC2 instances, elastic cloud compute instances. But I will use mostly virtual machine because it's just easy to say and write. So I will create a VM on a cloud provider, let's say Azure. Okay. Now, when this VM is provisioned, I am able to log into the VM as if it's a machine that I have access to through my keyboard and mouse. Okay. When I use VM, I don't have to, or I shift of responsibility, DA guy and Azure. So this whole networking, I am not responsible. This moves to Azure, right? This guy moves to Azure. Any physical or hardware, which is disk and all, this also moves to here. I don't have to manage, right? Any infra or hardware basically is this. So I am shifting part of my responsibility, which I was owning, to the cloud service provider. So when I am using a virtual machine, the cloud service provider is responsible for networking, servers, storage, power, everything. They provide me an operating system. They provide me a machine with an operating system. From that point onwards, up in the stack here, my responsibility starts. I am responsible for updating the operating system. I am responsible for installing everything else on the operating system, like information Internet Information Server or Apache server to run it as a web server, deploy, install the database, update the operating system as new updates come. I am responsible for that. But I am not responsible for the disk going down or the CPU heating too much or physical cable getting snapped somewhere. All those things are responsibility of the Azure or the cloud service provider. Okay, so when I'm saying infrastructure as a service, I am, or the Azure is providing me infrastructure like a machine as a service, because I can use it, I will pay for it, but the management of that thing is responsibility of the service provider, of the cloud service provider. So infrastructure, when I am using the service of a cloud service provider as IaaS, there from operating system onwards, upwards, I am responsible or I manage, but as the virtualization and server storage, networking, the physical hardware, that I am not responsible for. I am relieved of that responsibility. Okay. Now, for the PaaS system, what is the difference? A PaaS system is taking step further. I still have the same goal. I still want to write an application for the users to use, but now what I do is I develop the application. Okay, I have my code ready. I provision or I create an app service, or what we can say is that in general terms, I create or provision a web service on the cloud, server on the cloud. Okay, and web server, like not the physical machine like IaaS, Internet Information Server or Apache server or something like that, meaning it is called app service, which basically the cloud provider says you just deploy your code. I deploy the code of my app onto the web server. Okay, and it starts working. It can take requests from internet, and people can start using the application. For people or for the users of my application, there is no change, nothing. They don't have any clue what is happening behind the scenes. But I have slowly moved from IaaS to PaaS from on-premises, and nothing changed for the user. All changed is who is responsible for management so that the application keeps running. So in the PaaS, I don't have to even worry about operating system, middleware, runtime. Everything will be configured by the cloud service provider. I will just be deploying the app on my system and using the resources, the services automatically, and I am only responsible for my own application and the data. All I need to worry about is my application works properly from my code perspective, and it is storing and retrieving the data from wherever I want. Okay. The rest, the web server on which it is deployed, where it is running is not my concern. Whether the operating system is getting updated or not is not my concern. I am only bothered about my application and my data. Okay, so that kind of deployment where you are responsible for working of your application and your data of the application, that is called PaaS deployment. Other than these two, your service provider will take care of everything. Even scaling will be taken care of by the cloud service provider. Okay. So that is called platform as a service, because what you are basically doing is you are the cloud service provider is providing you the whole platform, meaning everything required for your application to deploy and work. It is giving you everything. It is giving you the space. It is giving you the compute capability. It is responsible for management of that. Everything it is providing you as a one service and one platform which you can use to run your application as you were running on the even the first case of on-premises. For users, it is same thing. So that case, you are responsible for your application and management, and others are responsible for, or a cloud service provider is responsible for everything else. So that is the platform as a service scenario. Now, software as a service. Software as a service is like you just want to enable some scenario or enable some business scenario that you want to handle, but you don't want to develop that in-house. You want to use existing solution somebody provides for doing that work. That is, you are not even responsible for application and the data. The application which you are using will help you with that. And software as a service there are so many examples. For example, the email clients that we use, they are software as a service. We don't code it, but it works for us, right? It provides us all the email capabilities. Google Drive, OneDrive, we store our data, we retrieve our data, we take backups, we auto upload our pictures taken from our phones to cloud to these Google Drive and OneDrive. These Google Drive and OneDrive are SaaS application, software as a service. So I'm using OneDrive as a service. I'm not responsible for coding that application. I'm not responsible for any bug fixing in that application. Neither I'm responsible for updating it. Automatically, everything is going to be taken care of by the service provider. All I'm doing is using it. Okay. So that is the extreme case where I still enable business scenario. Like in our DA example, what will happen is that we will have to make a deal with somebody who can provide that application to us, and we will use that application. Another example is digital signing. So, for example, in modern days, if I want to hire you, I will need your signatures on a contract document, right? So physical printout and calling you and then getting your signatures is one way. Another way is I can sign up for Adobe Sign or DocuSign. I create that agreement, I digitally sign it, upload it into Adobe Sign, and then Adobe Sign scans or processes that PDF file, and then it provides capability. It can ask me to create a box for signature wherever I want the other party to sign, and I will mark it that this is a signature box, or it should be it's a sign box, right? It could be others, like I want some third party to fill some details. It could, then that box could become a text box and all stuff like that, right? But for signature part, I can mark that box as that this is a signing area, and I provide the email ID of the other party and say yes, okay, set, and then automatically Adobe Sign will send that person an email, and with the link, that person will receive the email, click on that link, and then the agreement will be shown to that user. And then if user opts for it, user can sign there, then and there, and then Adobe Sign will verify that signature has been done, and the loop closes by it informing back to the first party that that person has signed, and you can download the copy and all. So whole document signing or contract signing is handled by Adobe Sign, which is an example of software as a service, because I get my work done of contract signing between two parties without having to own the application that is getting it done, right? So I don't own the application, I don't own the data in the sense what they are doing with the information with the scanning of the data, how they are managing the box creation and all. I'm not responsible for that. Right? All I care is that I upload a file, I ask a specific place where the other party should sign, and the other party is signing it back, and I get the document, signed document back. That's all I care about. So I don't have responsibility of application or the data that I used to get this scenario done. So that is an example of software as a service. So as you can see, from responsibility wise, we shift the responsibility from on-premises to infra to platform service, software as a service. Uh, these are different levels of responsibility that you want to have. Now, which one is better and which one is not? It's not about being better or not. It is about which one is more appropriate for your business scenario. Okay, and obviously it started all with infrastructure as a service in the beginning, 2007 or 8, I think. Amazon started giving the virtual machines on rent, where you could create a virtual machine and people can use it. So it started as infrastructure as a service, but quickly it started further into platform as a service and software as a service. Okay. So I hope this discussion would have made things more clear to you. The IaaS, PaaS, and SaaS models of delivery of cloud services and how they differ in terms of who manages what. Okay. The responsibility of management of various layers of the stack shifts from you, meaning the cloud service user, to cloud service provider, as we move from on-premises to infra to platform software. Okay. Any questions on this? Anyone? So let us take an example. So if I write an application, let's say photo library, okay, and I am using Google Drive API to write this application. So anybody who is using my application, I am using Google Drive at the back to store those photos, sort them in different orders, some common scenarios, which normally Google Drive will not provide me. I am using Google Drive API to store the photos. My application is being used by other people, right? So me as a developer is using Google Drive. Is it an example of, okay, what is this example as? Is it an IaaS, PaaS, SaaS, or on-premises? For me, developer, when I'm using Google Drive API to write an application which takes some data from user, like photos in this example, and stores it in the Google Drive with some other additional functionality. So for me, as a developer, am I using Google Drive as on-premises, as an IaaS, PaaS, or SaaS? Anyone?
Sir, I think it is PaaS, platform as a service.
Great. So why do you think so?
So that is because as the developer, what the person has to do is that only write the code of it, and the data uploading, downloading of data can be handled by the end user itself, and he or she doesn't need to care where the data is stored, where is it goes. So storing and managing of data, what kind of database is used, all that will be taken care by Google Drive, as you told. So we don't need to take care about that. That's why.
Okay, anyone else? Anyone else? So what is the difference?
So the code,
Yeah, go
the
ahead.
code will be only the code is being stored on the cloud, right? So all the resources will be of the user, personal user. So it should be on premises, right?
No. Let me explain it again. What I'm saying is, as a developer, when I'm using an API of Google Drive to store my data, am I using Google Drive as a platform as a service, or software as a service, or infrastructure as a service? I could at the same time be using, let's say, a SQL Server to store some user information that my users are logging in and stuff, some payment information. But as part of the whole development, one portion is I am storing the photos that my users of my application are uploading into Google Drive, because I use its API to upload and download the data. So in that respect, Google Drive is not being used with anywhere else in the application. I'm using only for storing the photos and retrieving the photos. But other things could be there. I could be using some other database and stuff like that, right? For this particular portion, as a developer, when I'm using this Google Drive, am I using it as a platform as a service, or I am using it as a software as a service?
Platform as a service.
Why is it platform as a service?
Because we are managing the application and the other databases if I are using other databases, and rest is handled by.
My question is only Google Drive. I'm using Google Drive, right?
I think, sir, it will be software as a service, because we are using the software of the Google Drive to store our data and then retrieve it. The purpose of that is storing data and then retrieving it whenever we want. That's the software. Right?
So there is an important. So I know, because this question itself, I mean, this scenario itself looks like we are developers and therefore it will be platform. But I think it is a software as a service. Why? Because when I'm saying I am using Google Drive, right? So my application is Google Drive. I am not talking, this application is Google Drive which I am using. I am not responsible for the Google Drive application. I am not responsible for the API that it provides. I am not responsible for the way it manages the data. All I care about is I send my data and you give me my data back when I ask for it, right? So as a technology, it is providing me a platform, but the cloud delivery model is a SaaS model, because I am not responsible for Google Drive API, or because that is the application, right? In this case, Google Drive is the application I am using as a cloud user, and I am not responsible for that application, right? So that is platform, that is a software as a service model for me, for the Google Drive part. But in the other portion, let's say I am deploying my application onto an app service, but which is the application that is my application getting deployed, right? So I am responsible for that application's data, because my users are using it. For them, it is a SaaS model, because I have provided them an application they can just upload the photos and download and manage. For them, it is a SaaS model, but it is my application. From my perspective, developer perspective, when I am using Azure App Service or AWS, whatever service they have for deploying your applications, that is platform as a service model, because the application that gets deployed, I am responsible for that data. Here, inside that application, when I'm calling the Google API, I am not responsible for Google Drive, right? I am just responsible for my data. So inside of that application, the Google Drive that I'm using is a SaaS model. So it is not always necessary that only the end user who are not technology guys, like a regular everyday person, only for them it is the usage will always be a SaaS model. Of course, for them it will always be a SaaS model, right? Because they will just be using application. WhatsApp we all use, it's a SaaS model. With this presentation software I am using, it's a SaaS model, right? But it could be a SaaS model for developers also, for something which I am not responsible for. That is a SaaS model. So it is little bit, if you think about it, you'll get it. The application in question here is Google Drive. Am I responsible for it? No. So therefore it is a SaaS model. In platform as a service, application I am deploying, yes, I am responsible for it because it is my application, right? So that will be a platform as a service model because the app service on which I am deploying this application is accepting application, but it is not managing my application. I am responsible for it. I decide where the data goes, when the data goes, which data goes. So I am responsible for both application and the data. So that is a PaaS model. When I use app service where I can deploy my application, that I am using as a platform as a service. Okay, I hope it is a little more clear. But don't worry, it's not too much of requirement to completely isolate everything in these three categories. You should have a general idea of basically the ownership. For example, when we use virtual machines, it is generally thought that operating system management is going to be Azure or cloud service provider's responsibility. It is not. You are responsible for updating the software there in operating system also. So we should just take care of such things. Okay, I think that is good enough for these cloud delivery models. Okay, great. So I need to start it.
Hello, sir.
Yes.
Sir, can you please explain the last example again, where you told that it is the responsibility of us to update the operating system and all? Can you please repeat it?
Yeah. So when you create a what do you say, a virtual machine, right here, the updates that come for operating system, when you will log into that virtual machine, you will have to check for updates and install them on operating system. Okay. Azure will not do it for you.
Yes, sir. So when we are talking about operating system, that is the system on which the virtual machine is running, right?
No, I'll show you. I'll tell you. Good question. I understand your confusion. So when we are talking about, I am using a VM. Just a second. I'm using a VM, right? So VM has this kind of structure. So there will be hardware part, which is like disk and all. There will be an operating system like Windows Server. Okay. On that, there will be something called Hyper-V, virtualization layer. Okay. And this Hyper-V enables installing different operating systems, OS, let's call it Windows 10, Windows 11, Windows Server 2019, like that. Okay. This is how it is done, and only this portion is exposed as one VM. This one is VM2. This one is VM3. Okay. So when I'm using a virtual machine, all I see is this VM and the Windows 10 operating system. When somebody else uses this VM, all they see is Windows 11 operating system, because I opted for that. When I started, I wanted to create virtual machine, I said I want Windows 10 machine. So the Azure picked up this Okay, so as a user of this VM, I am responsible for this operating system, this one. Okay, I need to get it updated and all. I need to, create users and everything on this operating system. And inside of this is all Azure's responsibility. So there is some operating system running on which hypervisor is running, on which then virtual machines are created. So what we are talking about here is this operating system. Okay, this operating, who is responsible for this operating system in IaaS? Us, the user. Is it clear?
Yes, sir. Got it. Thank you.
Okay. Is website in old is a SaaS system. So any website in my notes there is a question. I hope you can see it. Any website is basically a SaaS system because the user is just using it, right? There is no should not be any confusion there. Okay. What else we have got? What we discussed previously is cloud delivery models. They are so important, but one other thing is how the cloud deployment is done. It's not the deployment that you do on the cloud of your application. It's not that. It's that the cloud that we are able to use, how that has been deployed, or what kind of visibility or access level that cloud has. Okay. So there are public clouds which generally we are all aware of, like Azure public cloud. What public cloud means is that when you create a virtual machine, the underlying hardware is shared. I create a virtual machine in Central India data center. Somebody else sitting in South India or even in Assam, Northeast India, creates a virtual machine in the same data center. It might happen that the underlying hardware or the virtual or the server that is providing me and that person who is sitting far away in other corners of India is provisioned on the same. The virtual machines are side by side, like I just drew Windows 10 and Windows 11 over a Hyper-V, right? Not only that, it could be somebody sitting in the US but creating the virtual machine in Central India data center could be same. So public cloud, anybody can access. The data center infrastructure is shared, okay? And that is the common model that we are well aware of. As you can see here, the properties of the cloud, it is a shared infrastructure across different users. It's inexpensive and easy to set up. And then all these guys are examples of public infrastructure. So private cloud, it could be that large companies which have different centers of operations could be connected through wide area networks and stuff like that. So those guys will be having their own private cloud where they can deploy, they can use the virtual machines, they can access the resources using their IDs of that company. So that is private cloud. Now in that, our own data centers, your own data centers are part of that, but even the regular cloud service providers like Microsoft Azure and Google and AWS, these guys also provide private clouds to required business houses or government based on their deal, one-to-one deal that they do. So they will provide to the extent that, for example, let's say US defense related data, right? US security forces will be huge consuming and generating huge numbers of data. They don't want it to be shared across anything, anybody, right? They want all the data to be physically put under physical boundaries that they can access, right? But obviously, it is a headache for them to manage all that data. So if Microsoft offers that, okay, for US security forces, I will provide a complete exclusive data center itself for you, right? This whole data center will be only housing the data related to so and so US Navy and stuff. Okay, they might sound plausible for the US government to have billions of dollars in deal with Microsoft Azure because it relieves them of this issue that we had, right? In this case, they will be managing everything. Now they will not be managing the at least the hardware part of it, right? Half of this responsibility is gone. Maybe further down the line, more responsibility will be relieved and put on to Microsoft, right? So those are also examples of private cloud because nobody else has access to those clouds, only designated people. This could be same as this could be also not only the US government, it could be private house also, private business house also, right? So a business house like in India, Reliance, right? They are huge conglomerate of different businesses. Tata, Sons, huge business in different domains, right? So they might be thinking that yes, it might be better to depend on technology prowess of Amazon or Microsoft or Google and have a deal with them so that they can provide dedicated data center somewhere central India or something so that whole data is stored in that data center and retrieved from that data center, things like that. So that will also be private cloud. Business to business or business to government are examples of private cloud. Hybrid cloud is a mixture of the two. Some information could be private, some information could be on premises, and some could be on the cloud. Community cloud, I guess, will be open source cloud or something. So basically, we are 99% dealing with public cloud, but we should also be aware of that hybrid and private clouds are also possible. Okay, so yeah, this is also, we have 10 minutes. I think we should be able to discuss this. This is an important thing. But good thing is that we are going to cover a lot of details in this course about this. But just for the sake of comparison, like curiosity wise, that what is so much that the cloud-based systems provide versus the traditional one, and also to appreciate the challenges ahead, because many things that we assume as our knowledge base go for a toss or are different, completely different, when we try to apply or use the same things on the cloud. And we will hit many such scenarios, and that is one of the core pieces of awareness I want to go from after taking this course, is that on the cloud things could be different. Things could be the ways of doing things could be different or than the traditional ways of doing things. Okay, so very important to understand how the cloud-based systems is different paradigms versus the traditional ones. Okay, so in traditional systems, generally the application will be monolithic and centralized. In cloud-based systems, the application that we create should be actually split into different services, and they should be decentralized. Okay, don't have to understand everything, but you can get an idea that, for example, it is very common in software to use one database for the whole application. Not true for cloud-based system. You should not use it. Okay. Then we design for predictable scalability. That we traditionally we know how much the application should be could be used. If it is getting used more, we patch it up and all. The cloud-based systems is designed for elastic scale. The elastic means going up and down. Okay. Then generally traditional databases or relational database RDBMS are used in traditional systems. In cloud-based system, it is polyglot persistence. Poly means more, right? Glot persistence means saving. That is the mixture of storage technologies. One RDBMS or NoSQL is not a solution. You should use the solution which is more appropriate for this scenario. It could be only RDBMS, it could be only NoSQL, or it could be a mixture of both. So polyglot persistence is a common thing. Multiple or mixture of storage technologies is a common thing in cloud, which was not so in the traditional system. Strong consistency, because RDBMS was the case. Strong consistency meaning the data will always be consistent. One user will see the same data the other users will see. If a transaction has happened, it has happened for all users. If a price update for a particular item has happened, that new price from 100 rupees to 120 rupees is visible as 120 the moment the price is updated. And that visibility is for everyone who is using that system. Okay. Cloud systems are built for eventual consistency. So it is very much possible in cloud systems that I update the price of one item from 100 to 120, but it is not visible as 120 to everybody. Okay, it will become 120 to everyone eventually, but it is not immediately as soon as the price is updated. So that is a kind of a paradoxical that why will we ever need a eventual consistency? And we will discuss a lot of things on this, so don't worry about it. It's very interesting. Serialized and synchronized processing versus parallel and asynchronous. As we can see, horizontal scale out. It will always be parallel and asynchronous processing. So cloud, if you want to have a scalable systems, this has to be the key, parallel and asynchronous processing. Right? So that cloud mean if you are moving to cloud, the primary reason would be scale out, or you want to scale your application. So it must be parallel and asynchronous. Then we are used to building applications which are designed to avoid failures, and here we are designing for failure. So this term might be confusing. Design for failure. It doesn't mean that you design the application so that it fails. It means is design to handle failures or to be able to absorb the failure. Design for failure. Right? So it means that mean time to recovery. Okay, mean time between failures. So what measure we do is between two failures, how much longer the application could hold. That is generally the stability of the application. And here we say that how quickly an application can come back to its feet after a failure occurs. So mean time to recovery. That is the design for failure. Like how you can deploy, how you can design your application, how you can architect a solution in the cloud, so that if some portion of the application fails, does it bring the whole application down? Can your application run partially? What is the time it takes to bring the application back up and running again? Those kind of questions we need to answer in designing for failure. Okay. occasional big updates, frequent small updates. I can give you example from my own experience. Windows, when I was in Microsoft, used to update every 3 or 4 years. I work in Visual Studio team. If you know, Visual Studio is a IDE for programming. I worked in that team which created Visual Studio. So we used to release large updates every 2 or 3 years. Okay, so that is occasional big updates. Same company, example, big team. They update their software. They release their software almost every second because the team is very large. They have set up the system, automated system, which will, if you fix a bug, it will automatically go through testing and gets deployed. 1 or 2 updates in every 2-3 years versus every second update, multiple updates in a day is what the new paradigms are. Okay, it's a huge difference. That is why I said I was telling that this frequent small updates is one of the key to have business success because you can respond to failures, you can respond to customer feedback more quickly. People who can devise ways to enable small updates are IT and DevOps people. They need not to be programmers. There is huge demand for those kind of skills in cloud. Okay. Then manual management, automated self-management is fine. Snowflake servers, meaning the large servers and immutable infrastructure. These servers are prone to downtimes and all. Our infrastructure in cloud is immutable because of the virtualization. So these are the kind of, it basically projects quite a different world in terms of technology, design, architecture, and design pattern, solution, even coding. When we are, coding or when we are developing cloud-based solutions. Okay, so that becomes more important because now you need to be aware of whether you are working for a traditional application or are you working for a cloud-based application. And you need to be aware of if you are working for a cloud-based application, these are the things that you need to be aware of, and then don't, do the mistake or something like that. Okay. I think we'll stop here, and I hope you found the discussion interesting. And as usual, if you have any questions, please let me know. Otherwise, we can stop the lecture. Any questions, any feedback, any doubts? All right, great. Then have a good day and take care of yourself.